ठीक है बहुत लोग घूमते हैं तुम start.
Materials. So, for a magnetic material, when we are applying external magnetic field, then it will get magnetized or demagnetized depending upon which type of material it is. So, when you are applying a magnetic field to a magnetic material, then what will happen? Its magnetic moment will align along the direction of external magnetic field. So, you will get a overall net magnetization. Yeah. So, what is magnetization? It is the net magnetic moment per unit volume. Yeah. So, this is the instrument by using which we can calculate the how much magnetic moment is developed within the magnetic material when we are applying the external magnetic field. So this is the vibrating sample magnetometer by using, in short form it is known as the VSM. So by using which we can calculate how much amount of magnetic moment is generated within the magnetic material when we are applying external magnetic field. So we are applying the external magnetic field, we can do two types of measurement here. Means by keeping the temperature constant, we can vary the external magnetic field and we can measure the magnetic moment. And another measurement is the keeping the magnetic field constant. Suppose that 100 Western or 1000 Western, we are keeping the magnetic field as constant. And we are varying the temperature and measuring the how much magnetic moment is within the material. So here we can use both powder samples or pellets, means a small fraction of the pellet, or thin fillings. With the sample types are like this: either powder sample or a chunk of from the pellet or a thin filling. So this is the powder sample holder. Yeah, this is the Teflon capsule. You can see that there are two Teflon capsules. Within one Teflon capsule, there you can see that there is a white portion. This is nothing but it is just the powder sample is wrapped with a Teflon tape. This is the Teflon tape. This is the Teflon tape. Within this, the powder sample is wrapped. Why? Because within this, within the GSM, the sample will vibrate with a frequency of 40 Hz. So there is a chance of the sample is come out from the Teflon, from the capsule. That's why it is the sample is wrapped with the Teflon tape first. Then we are placing it within one capsule and another capsule is for the safety purpose, another capsule is used. And this is the brass sample holder. So if you already, all of you know about the VSM, how it is working? Okay, I will tell all of you. This is all about the sample part. You will take a small portion, then within the weight machine, you place the Teflon tape on a tracing paper or normal paper and put the sample here, then you will wrap it. It is, this Teflon tape is so narrow, so it will be difficult, but we have another Teflon tape which is little bit wider. So by wrapping the sample with that Teflon tape, it is little bit easy. Okay. So within the VSM, inside the VSM, if you want to see, I will show you. This is the interior of the VSM. Are you able to see, all of you?
Yes.
So you can see that there are two pole pieces of the magnet, which is at 3.77 Kelvin. So these magnets are the solenoidal magnets. That means within the sample holder, it is a solenoidal magnet, and around the solenoidal magnet there is also four pieces of pickup coils are there. What we are doing, we are placing the sample within the homogeneous magnetic field of the solenoid, and there is a piezoelectric material is here used. All of you know about the piezoelectric material.
Yes, yes.
When you are applying a electrical signal to it, it will create a mechanical vibration. The piezoelectric material produce a mechanical vibration of 40 Hz. Within the frequency of 40 Hz, the sample will vibrate within the homogeneous magnetic field. So what will happen according to Lenz law, when the sample will vibrate, then the magnetic flux linked with the sample, it will changes. So therefore, there are 4 peak-off coils are there. So what is the what is the function of that peak-off coils? When the magnetic flux will change, then that change in flux, magnetic flux will instantly collected by the peak-off coil, and it will be transferred to the electronic system to convert this change in magnetic flux to when there is a referral sample by using which it is standardized. So with comparison that standardized sample, it will calibrate how much magnetic moment is within the material. So from looking outside, we cannot place the sample within the magnetic field, homogeneous magnetic field. We don't know exactly where position within the where position. So first we have to so this is the Sandra is within 30 to 35 mm. Yeah. Then you can guess that your sample manually you are offsetting that your sample will be, you are guessing that your sample will be in the homogeneous magnetic field. There is also another the system will manipulate itself, but manually we are doing that. We are placing the sample here. Now it is, you can see that it is in between 30 to 35. Means between 30 to 35 mm. The sample is now it will place directly within the BSF, then it will be in the homogeneous magnetic field. Just why it is the sample, that is because it is wrapped within the definite. Yes. Yes.
गुलाबी टाइप का होगा, इसकी भी वाइब्रेशन अंदर होगा, पूरा सिस्टम ही वाइब्रेट करेगा,
Whole the system will vibrate.
मैग्नेटिक मोमेंट इसी में क्रिएट हो रहा है.
If the sample will vibrate, means if you pack it loosely, means this two Teflon caps will not be tied.
मैग्नेटिक फोर्स लगाते हैं तो वो मैग्नेटिक अलाइंड हो जाता है, तो ये गुलाबी के तौर पर है, तो इसमें पता कैसे चलेगा कि मैग्नेटिक अलाइनमेंट जो है वो हो रहा है, मैग्नेटिक फील्ड. ये तो ठीक है, सैंपल डाला, रिजल्ट उसमें आ जाएगा, बट हम माइक्रोस्कोपिक पर समझना चाहें कि उसमें मैग्नेटिक फोर्स है वो अलाइंड हो गया है, ये सब यह पॉसिबिलिटी देख लेते हैं.
In this instrument it is not possible, but there is another instrument that is called Moog spectroscopy. Within Moog spectroscopy you can clearly see the magnetic domains. When you are applying the magnetic field, how the magnetic domains are yes. In the powder thing, no.
क्या होता है, मैग्नेटिक मैग्नेटो
Sphere microscopy. Magnet optical sphere microscopy. And also if you want to see the thin film sample holder, it is the thin film, I can show you, it is the thin film sample holder. This is the thin film sample holder, within which here it is a thin film is placed, and over the thin film the Teflon tape is wrapped for the safety purpose, and exactly also it is also within the 30 to 35 mm. Yeah.
Okay, exercise
साइज ऑफ द सैंपल एडजस्टेबल
हम तो फिर वो सब्सट्रेट पे सब किए थे.
तो मेरा एक अलग सवाल है. तो जैसे आप अभी बोले कि वो सैंपल जब मैग्नेटिक फील्ड के अंदर ऑसिलेट होगा तो फ्लक्स चेंज होगा और इलेक्ट्रॉन सब ट्रांसफर होकर उधर जाएंगे.
नॉट इलेक्ट्रॉन्स, जो फ्लक्स ट्रांसफर होगा दैट जो फ्लक्स चेंज होगा तो फ्लक्स कितना चेंज हो रहा है. इनिशियली सैंपल में यूनिफॉर्म मैग्नेटिक फील्ड में रखा हूँ, तो इसका जो मैग्नेटिक फ्लक्स है तो वो नोट हो रहा है. जब मैं इसको वाइब्रेट कर रहा हूँ तो उसका फ्लक्स चेंज हो रहा है, तो चेंज इन फ्लक्स विल बी कलेक्टेड बाय द पिकअप कॉइल.
ओके, दैट
डाटा विल बी कलेक्टेड बाय द पिकअप कॉइल and it will send to the electronic system, not electron, it will send to the electronic system for the calibration.
इसके ऊपर टोटली मुझे काम करना है.
इसी पे. ओके, बढ़िया.
सैंपल का अमाउंट कितना रहना चाहिए मिनिमम?
पीछे है तो
Like 3
तुम्हारा फोटो आ रहा है.
मिलीग्राम हिसाब से
15 milligram, 19 milligram within sufficient. If it is a metallic heavy sample, then if you take a small amount of powder, then it will be like 15 milligram, 16 milligram. If you take a light sample like graphene or anything else, then it will within 3 milligram, 2 milligram we can do.
तुम्हारा फोटो खींचो.